Hi everyone, welcome to my channel. In this video I'll show you how to run STM32 applications directly into the cloud with ARM virtual hardware. This usually speeds up the development process and saves you from buying the physical hardware. So let's get started. Before getting into this video, I'd like you guys to know that I've started a free embedded systems community in which I'll be posting interesting articles related to electronics and IoT. By joining this group, you'll be able to have one-on-one calls with me and be helped with your projects. And so, for this you'll need to go to ARM Virtual Hardware. Click on the first link, and if you don't have an account, just register. In my case, I'll just log in. After you've created an account, it should prompt you to this panel. And so let's create a device which represents an instance of our hardware. Click on default project, and here are all the boards supported by this platform. And so I will choose the STM32U5, it is the last one here, so click on it. We can now choose the firmware version, which basically represents the program which will be stored inside. I'll choose HTTP web server, click select, I will leave the name as default, and create device. Now cancel this. Here is the console log. So let me tell you first how does this work. The board is configured as an HTTP server, and I will simply provide the IP address on the browser and I will be able to get an HTML file. The web page also contains a sensor data analyzer. I will show you later. So let's set the SSID to ARM, for instance, and the password to ARM as well. And now it started listening on the TCP socket. Because this platform uses a firewall, we will need to establish a VPN connection. So go back to Google and search for OpenVPN. Click the first link, go to Community. Now download OpenVPN Community Edition. And you'll simply need to download the version according to your machine. The next step is to download the VPN file. You can find it over here to connect and press download OVPN file. After you have installed the OpenVPN and have downloaded the OVPN file, you should see here on the bottom right side the OVPN service. So go here, right click on OVPN, press import, and you should now import the OVPN file. Now that you have imported the file, go back again and right click on the GUI and press connect. You should see this. Now that everything is alright, the board is basically connected to our network. Basically, the board is connected to our network, and you can find the IP address of the board over here. So copy it, paste it into the browser, and you should see the HTML page, which is pretty simple. It demonstrates what does a board offer. And there's another cool feature that this platform implements, which are the virtual sensors. You can plot real-time data based on the sensor readings. So go to temperature, and you should see here the graph. Press start, and here you can see 30, because the default value that the board is reading is 30. So how do you change the sensor data? Go back to here, go here to sensors in the left side, go to environmental, and let's change it to 100. Let's see what happens. You see, it changed it. Now let's see if you can see it better. Like this. Now let's change it to 10 again, and you should see that it decreases to 10. Press enter, and it goes back to 10. Let's press another value, for instance 200, and it should rise to 200 again. 200. Now let's flash the board with a custom firmware. And so go to CubeIDE, create a new project, and I will choose the BU5 board. And let's say an example. Oh, I have to use the name again. And let's choose the simplest program, which is IO toggle. Click it, then next, then finish. If it gives you this error, it doesn't matter that much because it tries to look for the readme file, and that doesn't matter. I go to this project. The only file we need is the ELF file, which represents the final result of the compilation. It is basically the exact file that gets stored inside the board. So just click this, then build, and it will simply generate the ELF file. Go to debug, and this is the file that we're looking for. Right click on it, show in System Explorer, because we will need its path now. Copy the path, go to the browser, click Settings, Firmware Binary, and let's upload our firmware, which is the ELF file. Now click Save and Reboot, and it will simply flash the board with this firmware. Now that everything is flashed, you can see over here that the LEDs are blinking. These are the LEDs that are used in the project. Now let's go to Application, User, Windows C, and we should see here the LEDs. Now let's increase the delay. For instance, make it 500. And see what happens. Now go back and upload the new firmware. Open. And click Reboot. And now they blink slower. So that's pretty much it, guys. I hope you enjoyed this video. Leave a comment down below what you think about this project, and I'll see you guys later.